Okay guys, you're not going to need your calculator for this lesson until right at the end because we're looking at how we classify data. So we're actually going to look at a load of words that we use when we describe the data that we have. So we're going to look at whether or not your data is qualitative or quantitative, whether it's continuous or discrete, random or biased, and whether you have an entire population or just a sample of that population. Okay, so let's have a look at what these mean. Also, before I forget, I'm setting you some homework. Now, this homework must be completed in a week's time, so a week today. However, it's going to make your life a lot easier if you complete it early for two reasons. One is because I'm going to set you a little bit more next lesson, and the other one is because one of the things that we're going to do the lesson after that is going to use some information from the homework. So it's going to make that lesson much easier if you've already done your homework. Okay. So, is your data qualitative or quantitative? Now, qualitative describes the qualities. It is descriptive, it's not numerical. So I might say to you, describe the softness of this cat. And you might say, it's fluffy. It's very fluffy. It's super soft. My hand disappears when I stroke it. Things like that. But you don't give me numbers. Quantitative data gives you quantities. So it's numerical. And it's the only data which we can use our statistics on. So you should be collecting quantitative data because otherwise we're not doing maths. So I might say to you then, describe the softness of this cat on a scale of 1 to 100, and you can actually give me a number. Now obviously that's quite a subjective question, but we do work with subjective answers in maths sometimes. Okay, so qualitative gives you qualities, quantitative gives you quantities, and we are only really interested generally in quantitative data in maths. Then we need to ask, is our data continuous or is it discrete? Discrete data can only take specific values. So for example, if I was going to count the number of students who take my maths class, I couldn't have 5.5 students. It would have to be 5, 6, 7, 8, whole numbers. So that is discrete data. It has to be certain values. And you can have discrete data that has halves in it if it can only be 5 or 5.5, 6, 6.5. For example, shoe sizes. Shoe sizes can have halves, but you can't have anything in between. Now, if I was going to measure shoe size in the actual size of the foot, so I was going to take a ruler and I was going to measure the feet to work out how big they are, that will be continuous data, because a foot can be any length within a range. Probably, if you think about a child's foot, be maybe about 5, 6 centimetres, and a fully grown adult's foot probably about 20 to 25 centimetres. So if we're talking about foot size, we'd be talking about any possible value between around about 5 centimetres and 25 to 30 centimetres. So that's continuous data, because my foot might be 25.56 centimetres. So it doesn't have to be an exact value. And really, the value that you get for continuous data depends on the accuracy of your measuring equipment. So if I was measuring feet, but I was using a metre ruler to do it, which didn't have millimetres on, I'm only going to be accurate to the nearest half a centimetre. But if I'm using a ruler that does have millimetres marked on, then I'm going to be accurate to the nearest half millimetre. And if I was using a ruler that had something smaller than millimetres, not that my eyes would be able to see that, I would be able to be even more accurate. So discrete data has to take on certain values. Continuous data can be any value at all in a given range. Okay, population or sample then. So a population is the total number of individuals in a given situation. So for example, we might talk about the population of our school, in which case I'm talking about all of the students, all the way from nursery up to DP2. I'm talking about all the teachers, all of the admin staff, all the kitchen staff, all the support staff, everyone. So that will be the population. Now, usually when I'm collecting data, a population is going to be too many individuals to collect data from, and it would take too much time. So I'd be looking to take a sample of that data. I'd be looking to come in and talk to some of the students, some of the teachers, some of the other staff in order to collect meaningful data. So we've got our population is everybody in that group. A sample is where I've gone in and only spoken to a select few individuals. The important thing when you're taking a sample is you want it to be what we call representative. Now what this means is it should have a fair spread of people or individuals. You're not always going to be looking at people, but a fair spread of individuals from across the entire population. So if I wanted to take a sample from our school, I shouldn't just go in and talk to year 9. I should go in and talk to everybody. I should take a few students from nursery, a few students from both receptions, and so on all the way up to DP2, and I should take a good range of the staff as well. So that allows us to avoid taking what we call a biased sample. If I was to only talk to students in one year group and only talk to the science teachers, that would be a biased sample. It would also be a biased sample if I didn't take into consideration how many males and how many females were in our sample. So in the population in the example here, 75% of the population are female and 25% are male. But when I take my sample, 50% are female and 50% are male. Well, that's not representative. Males are being hugely overrepresented in this sample. So I'd need to be careful and reconsider, recount and make sure I have 75 female and 25 male in percentages. I'd also need to think about how many students are in each class. So if nursery was really big, but the DP group was really small, I'd want to take more individuals from nursery than from the DP group. And I'd want to work out in percentages how much of the school they represented and make sure that my sample took the same number of students to make the same percentages. You should also be careful with your questioning when you're trying to collect random samples. So you might be using a survey in order to collect your data. So you need to be careful with the wording of your survey to make sure that your results are also random. So here I've got this question. You could ask it in two ways. Do you prefer greasy meat or healthy vegetables on your pizza? Now, that is almost encouraging the person that you're asking to be more likely to answer healthy vegetables because they want to appear more healthy. You're basically telling them there that meat is bad and vegetables are good. So you're going to get an uneven number of people answering vegetables because they think that that's what they should be saying. However, if you just went in and said, what pizza topping do you like best? They'd be much more likely to give an honest answer because you haven't given bias to your question. If we do, in some way, collect non-random data, so if I don't represent my population correctly, or if I ask for the wrong kind of information or ask the wrong question, I can't say that my data is representative of my population. It is biased. Okay, so have a look at page 46, exercise 2A. I'd just like you to work through that page and see if you can answer whether or not, or what kind of data there is there, whether it's random or biased. So pause the video here and try page 46, exercise 2A. Okay, this is the part of the lesson where you are going to need your calculator, because we're going to remind ourselves of the 3 M's and an R, the MMMR, the mean, median, mode and range. So I'm sure you've done this before. The mean is the average where we sum all of our values together, add them together, and then divide by the number of values that were there. So if I took 5 pieces of data, I'd add them all together and divide by 5. And that will give you your mean. Now generally it tends to come out as a decimal. So unless the question tells you otherwise, go to 2 decimal places. The median is the value lying in the centre when all of the values are placed in order. So you have to take all of your data values, you need to put them in order, and then the one that's right in the middle is the median. Now you might find that there are actually 2 medians, in which case you can take an average of the 2, or you can just say there are 2 medians to this data. So if you've got an even number of data points, you're going to end up with 2 medians. The mode is the most common number. It might be again that you have 2 or 3 modes. So if you have 2 or 3 numbers that are repeated the same number of times, then you might have 2 or 3 modes. It also might be that you have no mode. So if there's no repeated numbers, no repeated data, then you have no mode. And the range is the spread of data between the lowest, the very lowest point, and the very highest point. Now be careful here. Don't get confused with the range and the interquartile range. So the range just by itself is the spread from the lowest to the highest. The interquartile range is when you work out your lower and upper quartile. Remember how we did that using the calculator? And the interquartile range is the difference between those two. So be careful what the questions are asking you for. So you can see the median, mode and range are much easier to calculate if you've actually put your data values in order. And don't forget again, if you put them into the list in your calculator, you can get it to sort them for you. Okay, this is just a really nice little rhyme that can help you to remember which way round these go if you struggle. And if you like to have a song stuck in your head, just type this into Google and it will give you some interesting singing. So, hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that features the most, and the range is the difference between. It's just a really nice rhyme to help you remember which way round they all go, but you need to remember the rhyme correctly. Okay, so now you're going to go off and do pages 55 to 56, exercise 2F, practicing calculating your mean, median, mode and range. Now don't forget you can get your calculator to do this, okay? But do have a bit of practice of doing it by yourself as well. But I'm happy once you've done it once that you then use the calculator to do it. It won't work out the mode for you. And I don't think it will work out the range either, but do correct me if I'm wrong. Just a final reminder as well, this homework is due 1 week today, but the sooner you can get it done, the better. So if you finish the exercises that you're working on, this homework you can start. Okay, off you go.